Good afternoon, fifth hour. So sorry that I'm not with you today, but make sure that you treat Mr. Warner with the utmost respect and care, because as always, we are in K208, where the K stands for. That's right, kindness, you betcha. Anywho, your activity and video and everything's in Google Classroom, so make sure you've opened that up. And if you need to re-watch this video to clarify some things, or if you have questions, certainly feel free to reach out. I am over at Westwood DJing their Play 60 event this afternoon. For today, I'd like you to do both the in-class activity, the homework problems, and then also the Unit 1 progress check. Okay. Now, on the first slide here, I know it says, please measure your hand span, your spread from pinky to thumb. Measure it to the nearest centimeter, see how many starbursts then you can grab. Okay, rather than having you do that, record your data, I just had an example set of data of 13 values here. You can see them on the scatter plot. The big thing that you're learning about today is called the correlation. So the nice part is the Stacklet calculates it very quickly for you. The formula for how to calculate the correlation is in your gold packet. You will never have to do it by hand, but if you wanted to do it by hand, you certainly could. It's in there for you. But here is the correlation. Now, if you remember from Math 1, a perfect correlation with a positive sloped line, as you can see, would have a positive least square regression, okay? It's going to have a perfect positive 1. So all the dots, if they were in a perfect linear model, y equals mx plus b, you would have a correlation of 1. The dots form a perfect line. But as you can see here, certainly these dots aren't going to fall perfectly on a line. Okay, so if I put the least squares regression line in here, which we'll talk more about in a future lesson, you can see that the dots are not on the line. However, okay, a lot of them are relatively close. Some are a little bit further away. A couple that have a little bit larger residual value, but nothing that is too extreme. So that's why the correlation value you see here, it is relatively close to 1. Okay, so we would definitely say, in terms of strength, relatively strong. Okay, relatively strong. If you look at today's activity, these are some examples here to go through. So you see the correlations have been calculated for you. Now, why is this one positive and this one negative? Well, this would have a negative sloped line. Okay, doesn't matter the steepness of the line in terms of negative or positive. It's how closely are the dots to that line. Okay, so you can see this negative 0.96. The dots would even be a tighter formation to the line, if you will. Okay, this one, positive, but definitely more on the weaker side. Okay, and this one, really weak. Okay, so if an R value of 0, it's basically no association and whatnot. So as you go through this, it'll definitely help you to understand. So the first one there, fairly strong, positive, moderately negative, okay, very strong negative, okay, this one, a weak positive, almost no correlation, so very little on the positive side, but basically, they're kind of scattered all around. Similar to what you saw yesterday with the Star Wars check your understanding problem. That was a pretty weak correlation as well. And then the last one, the bottom right, about moderately negative. Okay? What is correlation measuring? Well, it's how closely the points follow a line. Okay? They use R, correlation. R tells us the strength of the linear relationship. And it also gives the direction. Okay, notice it's either positive or negative. That lets us know that the slope of the line is either going to be positive or it's going to be negative. Okay, moving on here. Okay, you can take a look at number 2. You can see positive or negative, and then how would you classify? And then take your best guess as the R. Okay, so this one would be positive. Okay, moderately strong. Okay, and the R because it's in the moderate value, it's going to be somewhere above that 50, 0.50. Okay, anything above that to about 0.75. Okay. Number 3, okay, hopefully you can see that if you put a line there, it would have a negative slope. And if we did put a line on there, how tight they would form to that line. So this would definitely be very strong. Okay, so what I failed to mention earlier, if it was a negative slope line, okay, a perfect negative slope, y equals mx plus b, that would have a correlation of -1, because all the dots would be perfectly on the line. So this one's going to be closer to -1, certainly not perfect, but definitely very close to it. As you can see, a line, imagine a line coming through here, and all the dots are relatively close, a nice tight pattern following that negative sloped line. Moving along here, okay, so this would be an example of a group's data, old school action, because we used the Barbie instead of the marble character, and we measured in centimeters instead of inches, okay? So you can take a look at the correlation, okay, very strong. Put a line in here following the pattern, okay? And then they added in for 12 rubber bands, and notice because this one is following the same pattern, okay, it's going to strengthen R, okay? When we add more points that are going to fall in the pattern, it's going to strengthen R. So this point here, that 12 rubber bands, notice the distance traveled is going to generally follow the pattern that's already been established, thus making R stronger. So an unusual point that falls in pattern will strengthen R. Okay? On the contrary, okay, if we have a dot that gets added in that doesn't follow the pattern, okay, notice that you see the line that generally flowing here with the majority of the dots, and then one that doesn't fall in line, that's going to weaken R. Okay, that's not going to strengthen it, that's going to decrease it. Okay, it's going to pull the line, it's going to have a larger residual, and thus weakening the correlation. Okay. And then here is another example. Okay, so we could take a look at it. The linear relationship between the explanatory variable and response variable, strength and direction. So we're interpreting correlation. Interpret R for the given Barbie data at the top of the page. So here is our R. Okay, we notice it's positive, and it's very close to 1. Remember, 1 is a perfect correlation. So interpreting this, okay, the linear relationship between the number of rubber bands and distance traveled is very strong and positive. So correlation gives us the strength, and it gives us direction, positive or negative. Those are the two things that we get from the correlation. Okay? Now, the coefficient of determination, R squared. Okay, this one's a little bit more complicated. You did this in Math 1 back in the day, but it was definitely something, historically speaking, when I taught Math 1, I knew students definitely struggle with this concept. Okay, so when you're interpreting this, follow the template given. Okay, so it's basically the amount of variability in our predicted outcomes. Okay, in this case, our response, the distance traveled. Okay, the percent that we can account for. Okay, the improvement, if you will. So R squared, written as a percentage. And basically all you do, literally, to get R squared is square the correlation. Okay, and that's how the two are connected. So you write this as a percentage. 97.4% of the variation in distance traveled, remember the variability in our y variable, our response, is explained by a linear relationship with the number of rubber bands. Okay, so the percent of the variation in our y variable can be explained in a linear relationship with the x variable, how much it accounts for. Okay, so another example of this would be how much your car is worth based on the amount of miles that are on the car. Okay, it's not going to be an end-all perfect accountability because you know the value of a car is certainly a lot more goes into it than just how many miles are on that car. How old is it? What's the age of the car? How many accidents have been in it? Has it made a trip up to the UP and it's been peppered with mosquitoes and all the stuff that gets inside underneath the hood? Yikes, okay? So there's a lot of more that goes into your overall price of the car, okay? Certainly, the rubber bands and distance traveled, it counts for a lot, but there's other variabilities that we have to take into account. So nothing is ever really going to be a perfect 100%. Okay. Notes for today: interpreting R. Remember, okay, it tells you the direction, positive or negative. It's always going to refer to it in a linear pattern. Even if it's not a linear pattern, it's going to tell you how close it is to a linear pattern. And then here's kind of a breakdown. Okay, remember -1, okay, perfect, strong, negative. +1, strong, positive. Okay, 0, weak, none. And then that moderate range where you get around 0.5 or -0.5. So as we move from negative and getting closer to -1, moderately strong to very strong. And then as we move from 0.5 to +1, moderately strong, very strong, and positive. Okay, those LY words, fairly, moderately, definitely help. Okay, and like I told you yesterday, taking a picture of this and inserting it into your notes for the test later, certainly a great idea. Sweet action for sure. Unusual points. Okay, so if we have an unusual value that falls in pattern, okay, an unusual point that falls in pattern, it's going to strengthen R. If we have an unusual point that doesn't follow the pattern, that weakens our R. Okay, R does not have units. Okay, in fact, if you change the X and the Y, it's going to keep the correlation the same. So it really doesn't care. If you look at the formula, it'll kind of make sense because it's multiplication a lot. And remember, order of multiplication doesn't really change the outcome. So it really doesn't care what is the response and what is the explanatory variable. If you flip them around, it's still going to have the same R. Okay? So changing units is not going to matter. Switching around the X and Y is not going to matter. Okay? And this, probably one of the staples of statistics. You've heard this before. Correlation does not equal causation. Just because there's a correlation, that does not mean causation. We can literally take two quantitative variables, put them into a scatter plot, and come up with some kind of correlation that is so random, so ridiculous. So keep in mind this phrase. Correlation does not equal causation. Okay? And then the coefficient of determination, R squared. It's the percent of variation in our Y variable. So how much our Y variable can change. That can be explained by a linear relationship with our X. Okay? All right, and then certainly take the time to go through the check your understanding. The answers are in the slides for you to follow along with and finish that up. So finish up the in-class activity, okay? And then do the homework, and you'll notice that the homework key is in Google Classroom as well. Okay, so you can check over your answers to the homework problems. When you're done with all of that, okay, so in class and the homework problems, log into AP Classroom. Okay, you can see every hour, first, third, and fifth. These are the hours that I currently have stats. First try, first hour, third hour, and fifth hour. Okay, make sure you are completing the Unit 1 progress check. There's 18 multiple choice problems. You can use your notes. You can work on it as a team. Okay, it's just a way to kind of refresh your memory of things that we've learned up to this point. Okay, and remember, everything in stats is cumulative. College credit, I will always let you know what's going to be on the assessment. But those of you taking the AP exam, anything we've done in class is fair game. So you really, really have to know this material inside and out. These progress checks that we're going to do from time to time once we've finished up a unit in AP Classroom are a great way to refresh your memory and be like, oh yeah, I remember this. Oh yeah, I remember this. Oh, I don't remember this. Oh, I better study it. Okay? So in-class activity, homework problems, and the Unit 1 progress check. If you get all that done and there's still time left in class, okay, obviously there's the pool table, there's the dartboard, there's cards, there's things of that nature, or certainly work on other homework. But remember, Mr. Warner deserves your utmost respect, okay, and treat him with kindness, because we know K208 stands for kindness. You betcha, changing lives. All right, and just one more thing. Phantom clap. 1, 2, 3. Oh, I love it. Have yourself a great rest of your day. If you need anything, reach out to me. Like I said, I'm over at Westwood DJ in their Play 60 event. Thank you so much. Take care. Bye-bye.